Okay. Good. So today is our last lecture, and it will be a short one because there is a meeting of all the faculty at 1:15. So we're going to have a last short lecture. Okay, and I would like to take a few minutes to summarize together what we would like you to take from this course, myself and the instructors. Okay, so I started here with putting the bread and butter. Okay, this is the bread and butter of Python programming, which we really want you guys to master and to be comfortable with. Okay, so I'm not going to go through everything, but this summarizes. You remember that in each lecture I showed the slide where I said what did we do last time, and every time we added something. Okay, so this is most of what appeared on this slide except for the last few lectures. And I wanted to take a few minutes with you guys so that you can have a quick look, and you have a chance now to tell us which aspects you feel you're less comfortable with, and we can adjust some material we will put on the Moodle, and we can adjust help we can give you toward the exam, because the bread and butter is the content of what you need to know for the exam. Okay, so take a few minutes, go through this, let me know if there is some aspect that you feel less comfortable with. Yes.
בטקסט שכאילו סיכומי הרצאות שיש במודל, המט גוטליב, אני חושב שזה היה מט גוטליב או
סייפיי,
אז כאילו בזה הסיכומים פחות היו גורם לשם.
אז מט גוטליב?
כן, אם אתם יכולים לעשות סיכומים.
Okay. So matplotlib, take a few minutes. This is your chance to ask for some more layers of practice. Yes.
איזה פעולות בתוך הספר אנחנו צריכים לדעת בתוך הנאמפאי והמנדט?
כל מה שעשינו בשיעור. Okay, and yes.
מה זה the is operator?
The is operator? זה היה איזשהו אופרטור שדיברנו עליו, שבודק אם שני variables זהים, אבל לא זהים We spoke about the fact that sometimes you can have variables which are not the same in memory. Okay, we went through this quickly. But this is one of the ways to check if two variables are equal and equal in memory, not only. Okay. But so this was in the summaries, but we can put a note in the Moodle to remind what this is. But if you print all the summaries, it's there, okay? But I will, okay, so I am adding myself another one, matplotlib, and so some more material on matplotlib and the is operator. What else?
About the code defensively. I think try except is more, we more tried it in the tutorial.
You did it?
In the tutorial, but the
PDB. Okay, so PDB, I remind you, it's one command. It's one command. I can show it to you. It's one command which is supposed to help you debugging stuff. So let's show an example. This is too small. Last time I'm changing the font. My computer is working hard on something I want to show you today, so it's very slow. Okay. 5. Good. And okay, so I remind you, PDB is just something that is supposed to help you debugging things. So if you do print hi, print the first part of my code, and then here you have the second part of my code, okay? And something is going on in the first part of your code which you're not sure about. You want your code to run until this point and then to stop, and then to give you a chance maybe to print a variable, to check if everything is working as expected. Okay, so it's a one command thing. You do pdb set trace, and then when you run your code it would stop at this stage, okay, and ask you to press C to continue, press Q to stop running. So just an easy way to debug things. Okay, my computer is working very hard now on what's going on in the background, but this is a very simple command, okay? Okay. Slide. Okay, so pandas, very important. Okay, I'm going to show in a minute the summary slide for all the commands that you need to be familiar with pandas. And when I mean familiar with, I don't mean you necessarily have to know all the different keywords and options of the group by command, but you need to know it exists, and you need to know the basics of how to use it, because if we need you to use it during the exam, you're not going to have time to learn it during the exam. Okay, you need to know it exists. Okay, and we haven't decided yet on the number of exercises, but in the exam there will be a strong component of pandas, and there will be part of the exam, probably one exercise, will be about checking that you understand an existing code. So we will show you a code, and we will ask you, what is this part doing? Why is this part wrong? Where do you think something is missing, etc. Okay, we'll show you an existing code, and we will check if you know what's going on. This will be one exercise, and the other exercises will be more traditional coding exercise, where we will ask you to write something from scratches. Okay? Okay, so this, as I said, was the bread and butter. This is what you will be tested on. Yes?
יש את הלוגינג, זה עם החמש רמות של הקריטיקל וזה, אז אני לא חושב שתרגלנו את זה בכלל בתרגול, ואני לא בטוח אם זה הופיע בתרגילי בית, ואני כאילו, אם אפשר כן לעשות איזשהו, כאילו, כן לתרגל אותנו איכשהו בזה, כי אני לא באמת בטוח.
I spent 2 lectures talking about it, but I can put some more material about it on Moodle. So I don't think, do we have another tutorial? I was told that you asked for a
תרגול
We have a
חזרה.
תרגול חזרה, נכון?
עם דורון, כן.
כן, אבל זה...
שכבר קבעו לו את הזמן שלו?
כן.
כן?
אבל זה חוזר
February
אחורה.
9th.
מה?
February 9th.
Okay, so but this is an opportunity to practice some of the things that you're mentioning. Okay? So I wrote to myself, logging matplotlib is
אפשר גם להעלות שאלות תרגול למבחן.
לא, כל מה שיש לכם בתרגולי בית, all what you got as homeworks is a very good way to practice for the exam. You will see also that we have very poor memory when it comes to code. So if you look at some codes that you wrote a month ago, you might not be able to recognize that it's code that you wrote. Okay, it's a very weird effect. Okay, we forget code very quickly. So if you want to practice for the exam, you can practice with the homeworks. You can check that you're able to do the homeworks with a pen and a paper without making too many syntax mistakes. Okay, the homeworks are a very good way to practice, and the things you did during the tutorials too. We're not going to invent exams from past years because we don't have exams from past years. Okay? כן.
לא, גם אני רציתי להגיד על הלוגו.
אבל it's the first year I'm doing this, so I mean I can invent more exercises, but they will be similar to what you got for the homeworks, okay? Okay. Now, the last part of the course, which we spent the few last lectures on, were beyond the bread and butter, okay? And they were aimed to show you that now that once you have the bread and the butter, you can really do many things that people a decade ago were not able to do from their laptop, okay? Python is giving you some superpowers to do a broad range of tasks, okay? This is really it gives you tons of opportunities to do all kinds of things that were impossible just a few years ago. And we gave two examples. One example was last time web scraping. Okay, so our goal is not to make you pros in experts in web scraping. We could spend an entire course on this. This wasn't the goal. The goal was to show you, to give you a taste of the kind of superpowers you can have with all the libraries which have been written by programmers in Python and which are completely open source. You can just pip install them and start doing some web scraping or code your own apps with or website in Python. Okay, we didn't do this, but there are libraries that helps you doing this. And today I'm going to spend some time on how you can do machine learning with Python in the same spirit, just by pip installing some machine learning libraries and just doing it on your laptop, which a decade ago was much more difficult. Okay? So, but this is not going to be part of the exam. This again is to give you a taste of Python superpowers. Okay? This is a slide summarizing the commands of pandas that you need to be familiar with. Okay? So, here too, make sure that you're familiar with all these commands, that you know they exist, that you know the basics of how to use them. Okay? And okay, and so now I'm moving to this part. Okay? Okay, so we mentioned it last time, machine learning is everywhere, okay? Even more so in the last few months. There have been a lot of discussion of what changed in the last few months. Why are everybody talking about it? And many people suggested that the only thing that changed is that it's now more accessible to us, okay? There hasn't been some algorithmic breakthrough in the last 2 months, but with OpenAI and ChatGPT and everything, it became very accessible to everyone and we became more aware of it being all around us. So I just wanted to show you guys, in case you spend the semester doing your homework with ChatGPT, I wanted to show you an example that I came across yesterday. I needed very badly to understand how a certain command worked, some rotation. So I asked it around which point is this command performing the rotation. And it answered me with full certainty that there is a parameter in this function which I just need to tweak. So I wrote to it. There is no. I wasn't sure. This ChatGPT was really sure. I wasn't sure. I'm sorry. I don't think there is such a parameter in this function. So it said, I apologize. You're correct. Okay. Then it accused me of having misspelled the package name. Didn't happen. Okay. So here I was more sure. Okay. I told it, you're wrong. This command doesn't exist. This parameter doesn't exist. And it apologized again, okay, and then gave another option. But this is just to show you. I think the danger in here is how sure it is that it's giving you the right answer, and it can be a bit unsettling, okay. And in this case, it was really wrong. I mean, but still, it ended up giving me a good answer, which saved me 2 hours of looking for it myself. So, okay, but this is something to be aware of. And it's really polite. It said, oh, I apologize. Okay. Okay, so let's say a few words about machine learning with Python. And here, unfortunately, I don't know what is your background in machine learning. I don't know if you have any background. I'm a bit traumatized from last time where I thought that all of you know what an HTML web page looks like, and I think it was a bit shocking to some of you guys. So, who has zero background in machine learning? Okay, good. And some people have some background. To which level did you take a course?
Yeah, I'm taking the data science course.
Okay, so it's going to be a bit boring to you, but we have to explain the basics. And here I'm showing you an example. This is the first paper, scientific paper that I wrote in 2015, where machine learning was starting to being used in astrophysics and in many other fields, and there was a trend of papers in the archive which were like doing doing with machine learning, like finding quasars, finding stars with machine learning. Now it's become completely, you don't choose such titles anymore because machine learning is everywhere. And just to give you an example of the tasks that we were trying to perform with machine learning at the time, sorry, someone is trying very hard to call me. Sorry about this. So in this case, we were trying to perform a classification task. Okay, we had images of the sky. Do you know what the difference between a star and a galaxy? So galaxies are big clusters of stars. Okay, our galaxy is called the Milky Way. So galaxies are big groups of stars. Okay, and stars, we see them at night. They are just dots of light. Okay, but basically galaxies are ensembles of stars. Okay, and in the sky they look pretty different. So this here is a galaxy. Okay, it has this shape. And this is a star. Okay, it looks round and it's like a point. And there are many cases where really we're not sure. For example, in this case here, we're not quite sure whether it's a star or a galaxy, and it happens to be a very important question in many analyses in astrophysics. If you have an image of the sky and you need to perform some analysis, you need to know if you're dealing with stars or galaxies. Okay, it's a very basic questions, and in many cases we don't have a good answer. Okay, so I will come back to this in a second. Okay, this I'm going to mention in a bit. Okay, so this is to explain you the basics of one kind of tool that people are using in machine learning, which is called a neural network. Okay, so maybe before I show you this slide, does someone know what a neural network is? Okay. Tell me what you know about neural networks.
It's a method of simulating a calculation and trying to basically gradually get a series of calculations to come up with the right answer.
Okay, so there are some true things. It's using a gradual process. Okay, it's trying to get the right answer. So it implies that we know that there is a right answer and a wrong answer. Okay, what else? Why do we call it a neural network?
זה דומה למוח, יש לנו נוריונים.
Okay, so
ליאור.
Lior said it looks like our brain. So originally it was thought, okay, the first neural networks were designed in a way that mimics what we knew at the time about the way our brain functions. Today we are not sure anymore. Okay, they kind of separated the fields of machine learning and brain study. Okay, we're not quite sure anymore how similar they are, but it's true that the neural networks are using these units that are called neurons. Okay, and which are connected one to another. Okay, and what else can you tell me about neural networks? Do you have examples where you know they've been used? Do you know of such examples?
Tesla.
recognition.
Tesla's image recognition. Yes. Okay. Okay. So we'll try to give some more general statements about neural networks. So it's inspired by the structure, or at least what we thought to be the structure of the human brain. So it has several layers. Okay. Here we have 2 layers. Here 2. And these units are called the neurons. Okay. And these nodes, the neurons, are interconnected. Okay, and the important thing is that we have an input information and an output information. Okay? Now, the cases where we want to use neural networks are cases where we have a clear sense that there must be a link between the input and the output, but we're not sure what this link is. Okay, I will give you an example. I think by looking at this image with the stars and the galaxies, okay, I think there must be some link between the color of the object, the shape of the object, the size of the object, and the answer, okay, of whether it's a star or a galaxy. Okay, I have good reasons to suspect there is some link between them, but I don't know what this link is. Okay. I'll give you another example. So neural networks were used in early days and are still used in airports, okay, to try to find suspicious suitcases. Okay, so people had this feeling that there must be a link between suspicious suitcase, okay, the ones that have bombs in them, how they look, and whether they have or don't have something problematic in them. But we don't know what the link is, okay? We don't have an equation that links the color of the object in the sky and whether it's a star or a galaxy, okay? But we suspect there must be a link between them. And we want a machine to find this link for us, okay? And to learn the way they link, okay? We want the machine to find the relationship between the inputs and the outputs, to learn it, and then to apply whatever it learned on new cases where we don't have the answer. Make sense? Okay. So Okay, and if we want to write it in a more mathematical way, so we have an answer. Here I called it C for class. Okay, for example, whether it's a star or a galaxy. I will show you in a bit cases where we're trying to classify images of cats and dogs. Okay, so we have good reasons to suspect that there is a relationship between the properties of the image and whether it's a cat or a dog. Okay, so this is the class. Okay, this is a function f that we don't know its shape. Okay, these mk's are the input properties. Okay, and these wij, these are what we call the weights. Okay, you might have heard this notion in relation to neural nets. So these are the weights. These are parameters. Okay, there are parameters which characterize each of the connections between the neurons, and they enter this function. Okay, so let's try to illustrate it with an example. Okay, so in this case, so this is a galaxy, this is a star, and I have this image of the sky, and I have good reasons to suspect that the class, okay, whether it's a star or a galaxy, is related to a whole bunch of parameters: the shape of the object, the color of the object, the size of the object, and maybe many other things that I don't know about. Okay, and I want the machine to come up with a function, okay, which links these inputs with the final answer. Okay, and to give me the answer, what is the function that links between them? Yes.
אז כאילו זה מוגבל למוח שלנו, כאילו לאיך שהתפיסה שלנו רואה. אם יש משהו שהוא מאוד כאילו לא כל כך ברור ואנחנו לא יודעים להגיד בדיוק מה זה, אז גם הרשת לא תדע להגיד מה זה.
בסוף אנחנו קובעים אם להשתמש בניורל נטוורק במקרים מסוימים. זאת אומרת, בסוף זה כלי. אז זה נכון אנחנו קובעים האם המקרה הזה מתאים לשימוש בזה, כן או לא.
אני מתכוון שכאילו שאת יכולה להגיד זה גלקסיה או זה כוכב, לפי מה שאת יודעת. את מבינה? כאילו דברים שאנחנו... היא כאילו מוגבלת למה שאנחנו מרגישים.
כן, אבל אני יכולה...
מה שאנחנו מבינים.
I can also give it here. I showed these properties to give you a good feeling of it. But you can also decide that you don't want to start thinking what are these parameters which will point me to the right class. You give it all the image as input. You throw to it all the image.
זה כוכב, זה גלקסיות ושהוא יבנה לבד.
יאללה, אתה נותן לו את כל התמונה ושיסתדר.
But you also need a data set that you use as a training set.
Okay, so I will reach this in a minute, but the point here is that you can throw to it a lot of information. You can give it the hour at which the image was taken, if you want. But you understand that it's probably not going to be related to the answer. Okay, at the end, it will perform better if you give it relevant information. But you can throw at it whatever information you want, and it will learn for itself which one is the relevant information. Okay? So another example, okay, which is the example that my computer is now running on and being very slow. So these are pictures of cats and dogs, okay, and we know that there are some characteristics in these pictures that make it a cat and other that make it a dog, okay? Otherwise, how are we able to say this is a cat and this is a dog? Okay, there are some features in this picture that tells our brain this is a dog, it's not a cat, okay? But we don't know exactly to point them. We don't know, okay, it's very hard to tell the computer, look at how the ears of the dog looks, okay? The computer doesn't even know about ears, it just knows about pixels, right? So in this case, okay, I just gave these as examples, but of course the shape, color, and size here are replaced with other properties of the image. Okay, and here the answer is whether it's a cat or a dog. Okay, and we want the machine to receive these images as inputs and to learn for itself the relationship between the image properties and the true answer. Okay, now there is an important, I'm now giving you all the jargons, and I will point you at the end at, I will show you an example of a neural network running on my computer now, and I will also point you to some tutorials if you want to do it for yourself. But here I'm trying to give you all the jargons that is usually not explained in machine learning Python tutorials, because people assume that you already know everything. Okay, so I'm giving you now the jargons so that you can read these tutorials and understand something. So hyperparameters versus model parameters. So I told you that what a neural net is trying to do is to connect between some input information and an answer. Okay, the answer can be a class of an object if I'm doing some classification. It can also be a property. Okay, I don't know. You're showing images of many people and you want to get the age of the person. Okay, and we know that they are somehow related. How the person looks and the age. Okay, or in astrophysics, the redshift of an object. Redshift. Okay. Okay, so the redshift and the colors. We understand that they are related. We don't know exactly how. We want a machine to figure it out. Okay, so we have these parameters that are called the model parameters. Okay, which are the input parameters and the weights. You remember I told you about the weights, which are these numbers that the neural net is going to tweak to come up with the right function that links the input and the output. And there is a whole bunch of what we call hyperparameters, which are not completely, which are not part of the model. They are not the inputs, they are not the weights, okay, they are not strictly related to the function, but they are more characteristics of the network. For example, how many layers do I put in my network? Okay, if I put 5 layers or 10 layers or 20 layers, my network is going to learn things at a different speed. It's going to give a different kind of answer. Okay, so what we call the architecture, this is part of the hyperparameter. So it can be the number of layers, it can be the number of neurons per layers. I can decide that I have 5 neurons in the first one and 20 neurons in the second one and 1 neuron in the last one. Okay, and here there is some amount of just trying and checking, okay, of ניסוי וטעייה. And in many modern tools, in the 2 libraries which I will mention, there is some process that you can do to optimize the architecture of your model, okay, of your network. מבין? כן, זה כזה. Okay, so okay, but here I'm doing the distinction between the parameters of the models, okay, which are the inputs, for example, the images or the color of the galaxy or the shape of the object, etc., and what we call the hyperparameters, which are everything that is around and is telling me things about the model. For example, what architecture did I choose? What number of layers? What number of neurons? Okay, and this too is something I will want to optimize over. Okay, but it's important to make this clear distinction. Make sense? Okay, good. Now, as you said, when we speak about neural network, we are in presence of what we call supervised learning. What does it mean? It means that we are teaching our machine, our network, to do something based on cases where we have the answer. Okay, so for example, I have a bunch of objects which I know are stars. Okay? I have a bunch of objects which I know are galaxies. Okay, so I'm going to give them to the network. I'm going to give them these images, and I will give the network the size, the color, the shape, all the parameters which I think are relevant. And I will tell them, in this case, you need to reach the answer that this is a star. Okay, I'm teaching it. The training process, it means that I, as a user, I'm teaching the machine what is the output in some specific cases. Okay? So,
או למשל בתמונה הקודמת, כאילו את מביאה לו כל מיני תמונות, ואת אומרת לו כאילו באיזה מהן כלבים וחתולים?
כן, exactly. I'm telling it, so in the examples of the cats and the dogs, I'm giving him a picture, I'm telling it, this is a dog, okay? The function that you will come up with, the function it needs to give the answer with this set of input parameters, okay? I'm giving you all the properties of the image, but at the end you need to tell me that this is a dog. Okay? This is what we call training. The training is the phase where you're teaching the machine on a subset of examples where you know what the true answer is. You're teaching it what is the true answer.
חשבו שהמוח שלנו עובד?
כנראה, probably our brain is working in this way to some extent. Okay, when we're learning, what does it mean that we're learning? We're learning what is the answer in some specific cases, and then we can extrapolate on cases where we don't have the answer, right?
Yes. So how does the network exactly generate the function to learn all the images that you give the
Okay,
information?
so it's actually easier before we go on images. It's easier to think about it in terms of inputs, okay? Because when it's taking images at the end, it's extracting properties from the image, okay? It's doing some. I will come to it in a second, but it's easier to think about it about a list of properties, okay? So, for example, the shape, the color, the size. Okay, and about the cats and the dogs, you can think about it as an additional step here, okay, where it will do some image processing. It will manage to measure the size of the ears, okay, or the color of the skin, okay. So it's easier to think about it first in terms of properties. So it's receiving all these properties, okay, and then what does it do? Okay, it's important to understand there is no magic here. What does it do? It optimizes a function, okay, which is called the cost function. It tries to minimize the function. This is the function that it tries to minimize. So this is the function that it will suggest, okay? It's a function of the input parameters and the weights, okay? And this is the true the answer that we give it. Okay, so I'm telling it, for example, if it's big, white, and elliptical, the answer is that it's a galaxy. Okay, so it will come up here with the function that gives me a galaxy in those cases. Okay, so during the training, the tool is doing an optimization process. Okay, it's coming up with the function, okay, that minimizes the distance, okay, between the true answer that I'm giving it and the answer that it gives. Yes. Okay, it's doing an optimization. It's solving an optimization problem, okay, which depends on the inputs. It depends on the weights, but this is super important. It needs the true answer. It cannot just invent the true answer.
So actually, it's classifying, right? It always takes the properties, and you try to classify.
Yes, so it takes the properties. It tries one function, okay, and then it checks. Okay, is it giving? It gives one answer. Then it compares the answer to the true answer that I gave it. If it's the same, it says, okay, I'm on the right way. It changes a bit the parameters, do it again. You understand? It's doing some optimization process where it's trying to fit, okay, it's a fitting problem. It's fitting its own answer to the answer that I'm giving it. And this is why we need to teach it. We need this training process where it's doing this fitting thing, okay? Make sense? Okay. Then, once I've taught it, okay, what the best function is, okay, I've trained it on many cases. It optimized the function that links the input to the outputs, okay? It now has the best function that always gives the right answer if I give it the inputs, okay? Then I can give it some cases. This is what we call the testing phase, where I'm giving it cases where I don't know the answer. I don't know the answer, but I taught it on other cases what is the link between the color and the answer. I taught it what's the link between the shape and the answer, okay? So now I can give it some images where I don't know the answer, and it will apply the same function that it learned on those cases and give me the right answer. Okay? This is the idea, the basic idea. Okay, so during the testing, the neural network applies the link that it learned to new cases where we don't know the answer. So this tells you already two things about training sets. Okay, A, they need to be big enough, right? Because if we teach it, if we give him a training set with one cat and one dog, he won't have enough cases to optimize a good function, to give a good function, okay? So if I have a lady dressed in pink on the picture with the dog, it will think, so there must be pink on this picture so that I say it's a dog, okay? But then if I give it a picture without any pink on it, okay, so...
Or someone with a shirt that has a dog printed on it.
Exactly. So you need to give it enough cases, okay, so that it can optimize its answer. This is one thing. And B, the cases that you train with, they have to be representative of the cases that you will ask it about. I'm giving you an example. Let's say I'm giving it only pictures at night time. Okay? So it's becoming really good at identifying dogs at night. But then I give it, so all the dogs that it's looking at are black. Okay? Because it's dark. And then I'm giving it a picture where I don't know the answer, but it's on the daytime. And it's never seen a white dog, okay? When I trained it, it's never seen a white dog. So if I don't give him cases, if the cases where I don't know the answer are not represented in the training set, it's going to perform poorly, okay? At the end, it's a machine. It's not creative, okay? It's just applying a good old link that I taught it in the training process. So you need some training sets which are big enough and representative enough of the question that you don't know the answer for, okay? Okay, and one last aspect. Okay, one before the last. So validation set, maybe you might have heard this concept before. So very often it's not enough to just train your algorithm. You need to save a piece of the training set for what we call validation. And this is to prevent a situation which is called overfitting, where your model is becoming very, very complex and very sensitive to the specificities of the training set that you gave it, okay? And then it's going to be bad at generalizing what it learned to something that is slightly different, okay? So, okay, it's many concepts for the first time you're hearing about neural network, but the point here is that you always need, and in many tools, the reason I'm saying this is that in many Python tools, you will be asked for what fraction of the training set you're keeping for validation, okay? So in many cases, the tool will request that you keep a fraction of the objects for validation, so that it can prevent these cases where the model is overtrained, okay, and it's trained and it's matching too much the very specificities of your training set, and it's going to be bad at generalizing it, okay? Okay, now you might have heard about convolutional neural network as opposed to just neural network, and the key point here is that they are optimized for image recognition, okay, for image classification, and the point here is that there is an additional step somewhere where it's doing some convolution on the images, so actually filtering the images to extract information from it. Okay, so it's doing the step between just looking at the image of the cat and the dog, okay, and then extracting these inputs which will go into the neural network. Make sense? For our purpose, what you need to remember is that convolutional neural nets are just one category of neural nets which are optimized for image processing. Okay? So if I want to classify images, or if I want to classify, I don't know, properties of some data, I might not choose the same tool. Okay? Okay, now I'm zooming back to Python. Okay, in Python there are two big libraries, very well documented libraries, which you can use to perform machine learning. One library is called scikit-learn. Both are open source. Okay, I hope you understood that this is the beauty of Python. Everything is open source, everything is free. Okay, you don't have to buy a license. It's amazing. Because you don't have to buy a license, it's so well documented because people are just using it. Okay, the more it's used, the more documentation there is online. So scikit-learn is a very good package for machine learning. It has a broad variety of machine learning tools. Today we only spoke about neural networks, but there are many more kinds of machine learning tools. There is supervised and unsupervised learning, and within each of these categories of machine learning, there are a large zoology of different tools that you can use. If you heard about decision trees, maybe, I mean, neural nets are far from being the only tool you can use in machine learning. So scikit-learn, I would say, has a broad varieties of tools you can use. And there is another package called TensorFlow, which it exists in several languages, not only Python. And it's primarily focused on neural networks. Okay, so I would say this is maybe the distinction between them, but both are very well documented, and both are relatively easy and friendly to use once you know these key concepts which I just went through. Okay, so there are two very good tutorials that I recommend. I'm now focusing on TensorFlow. Okay, Keras is the wrapper of TensorFlow that is used in Python. Okay, and there are two very good tutorials for just starting with image classification. So one of them is general to TensorFlow, and they show you, the nice thing about these tutorials is that they come with a set of data that you can download from internet and do the classification on. So in the TensorFlow image classification first steps, you can classify images in 5 classes of flowers. Okay, so you have rose, dandelions, sunflowers, tulips, and another class, I don't remember. And you see that the images are pretty different, okay? So this is an example. If you gave it 2 images, it might think that this windmill is somehow related to the type of flower. It's not, okay? And the Keras image classification from scratch, it lets you classify cats and dogs, okay? So I wanted to show it to you running. I started to run it before the lecture so that it might have finished. It still needs some time, okay? On a regular laptop, it needs some amount of time to run, but nothing to do with what you needed a few years ago. Let's check if it finished.
You're training it? What takes time?
Okay, so I'm not sure why it restarted it came to the end and restarted, so I'm gonna stop the run and I will, this is some code that I will put in the Moodle for those of you who want to give it a try. But let me show you the first stages of this code, and this is pretty much from the Keras tutorial about cats and dogs. I'm going to show you the first stages. So TensorFlow, you just install it with pip install, okay? Very easy to install. This is the installation command for it. And what I wanted to show you, okay, I'm going to run things until here. So you see that I'm putting here a PDB because I wanted to stop.
זה מראה כאילו, זה עושה לך אור שאין לך את הטנסור שלו.
איפה?
למעלה.
כן, אבל יש לי אותו. Okay, so I'm running it now from the command line. Okay, so here it's just showing me at some point in the code, I'm just asking it to show me the 9 first images in the training set. So you see that these are the kind of images it has. Okay, I've downloaded from internet a few thousands of images of cats and dogs. Okay, and I've put them in distinct directories of cats and dogs. I didn't do it, the person who made the tutorial did it. Okay, and you see that so all the zeros are in one directory and the ones are in the other directory. So this is something that, of course, you need to do in advance, okay, to organize things in 2 different classes. But by doing this, you're telling the algorithm, these are the 2 classes of things that I will want you to classify in the future. Okay, so you need to find a function that would put pictures with zeros. Okay, so these and the ones with ones in 2 different classes. Okay, these are the different classes which I want you to classify. Okay, as opposed to I don't know, like what other classes do I have here? I have a class with the grass on the picture and the class without grass. Okay, I could have tell it this is one class and the other ones are one class. Okay, you need to tell it, to teach it which are the relevant classes that you want to classify. Make sense?
This is like the teaching process?
Oh, this is even before. This is you organizing your training data in different classes. Okay, so that this image will need to give answer A, this image will need to give answer B.
איפה את מראה לו שזה חתולים? את צריכה לעשות אותו דבר כאילו ולהגיד לו זה חתול, לא?
לא, אבל פה הוא לא יודע מה זה חתול וכלב. הוא יודע שהאפסים והאחדים זה צריך להיות, זה התשובות השונות, אוקיי?
אוקיי.
וככה הוא מסווג.
הוא צריך לדעת it needs to know that the function that it will create will give distinct answers for objects in the class 1 and objects in the class 0.
אוקיי, זה יכול להיות 2, 3, 4...
כן, המספר פה לא חשוב, אפשר גם לקרוא לזה קאט
לא, כאילו זה לא בוליאן, זה 0, זה לא 1, זה
זהו,
כן.
אני חשבתי שזה...
ככה זה היה כאילו נראה, כאילו 1 זה כן, ו0 זה לא, הבנת כמו בוליאן.
כן, נכון, אבל... וגם ברגע שיש יותר משני קלאסים, אז... אבל מה שחשוב להבין פה זה שהוא לא יודע מה זה חתול וכן. הוא יודע מה הקלאסים השונים, אוקיי? Okay, and then there is another step which is performed here in the code, which is called data augmentation. Okay, so I told you that the training set needs to be big, right? I told you that the neural net will perform poorly if I don't give it enough cases to train on, right? So one way to artificially increase a training set is by doing what we called
Permutation.
Yes, is by doing what we call training augmentation. So this is an example. I started with one picture of a cat. קצת מטרידה התמונה הזו. מטרידה חתול הזה, אבל what did it do? What did it do? It flipped the image. I think it made some, it made some rotation, some mirroring, maybe a bit of scaling too, so that artificially I'm showing it more images. It's actually the same image, but it's like more similar cases. Okay.
And it's classified it to one class, or?
Yes. So in the code, I'm telling it. Augment each of the classes, take the images and flip them, rotate them, do all kinds of things that will artificially augment the amount of images in each of the classes. Okay, but I'm telling it, these should all be cats, okay? They're still cats, but make more of them, okay? And there are other ways to augment, okay? I could change the color, I could draw something on them, anything that would not affect the fact that this is a cat, okay? Anything that will not turn this into a dog will be good for data augmentation. Okay? Okay, now it stopped running because the next stage is actually making the model, so I will just show you what it looks like. So here it's making the model, so it's basically deciding how many layers do you want in the neural net, how many nodes do you want in each of the layers, okay? These are things that you can change, and as I told you in Keras, there is a framework for optimizing these hyperparameters, the architecture of your network, okay? And then after you've defined the model, you actually run it, okay? And at the very end, you give it a new image that it doesn't know the answer on, and you ask it, okay, is this a cat or a dog? And if you trained it, it will tell you this is a cat with an 80% probability and the dog with a 20% probability, and it's working and it's amazing and it's running on your laptop and it needs like an hour to train and that's it. So yeah, I think you don't realize how amazing it is, but you can do crazy things without much skills nowadays. You can build a tremendous amount of things by doing import blah. Okay? So I think this is my main message to you guys at the end of this lecture, that Python programmers have put all these amazing tools available for you guys, and now the sky is the limit. Just decide whatever you want to do with it, but there are a lot of things that you can do with it.
It's really crazy.
And this will end our lectures series on Python. Questions? I need to go soon to this faculty meeting, but
In your research, you use only נו, איך קוראים לזה?
artificial
Supervised learning, or
Yes.
you use also unsupervised?
So I use the supervised learning. So supervised learning is really good for classification. I had all these cases. So in astrophysics, there are cases where you have spectroscopy data, and then this is giving you a definite answer whether it's a star or a galaxy. Okay, if you have a spectrum, there is like you cannot confuse between the spectrum of a star and the spectrum of a galaxy. So we have all these cases where we know the true answer, but we don't have many spectra. We have less spectra than just imaging data, and so we trained it on spectroscopy. We also trained it on space images, because from space it's much clearer whether things are stars or galaxies, because you don't have the atmosphere, you don't have a lot of things that are blurring your image you don't have in space. So we trained it on spectroscopy, on space data, and for us at the time the problem was that we had, with traditional tools, we had like 80% good answers, and to reach the next breakthrough in the science that we needed a 99% accuracy on whether it's a star or a galaxy. And it allowed us to, we optimized the classifier, we went through an entire process of optimization of the tool, and it did the job. I would say that one danger is, as in all these tools, as in ChatGPT, as in all these tools, is to forget that they are not magic and like see them as black boxes without really understanding what they do. But
When supervised, you mean by human?
by supervised, we mean that it went through a training. There is another class of tools in machine learning where you don't tell it the classes in advance. So, for example, if I have this...
So it has to learn by itself?
Yes, so if I show it the... but these are... It's good for cases where you don't know in advance how many classes you have. So let's say that I have a data set and I don't want to separate dogs and cats, okay? I'm saying I think that there are 5 categories of classes here. I'm not quite sure what they are. Do the clustering yourself, okay? Do the classification yourself. So it doesn't make sense here because we know that we want to separate cats and dogs. But let's say that you have some heterogeneous data that you know there should be some things in common between groups of images, but you don't know what. And you want the computer to suggest you, okay, these are all green images. These are all, okay, so for this you do unsupervised learning, where you let the machine decide which clusters, which classes you want. But it's less, you wouldn't use it for classification issues like this. I heard once that one of the things that it's used for machine learning is to predict how much money you need to put in Kaspomat, cash withdrawal, ATM. Okay, so in each ATM there are different trends of paces of how quickly people are withdrawing cash, in which hours of the days, etc. And for a long time it was an issue for banks that they didn't know when to fill the ATM with money, okay? So what did they do? They trained for like 1 week, they declared, okay, this is training. For 1 week, there was an algorithm inside the ATM that learned, okay, the cash is withdrawn in these hours and this amount, etc. Okay, and then they rerun it on the next week's schedule, and it was able to predict when the cash will be withdrawn. Okay, so it was used to learn some patterns that the bank, they were assuming there are some patterns, but they didn't know exactly which pattern. So it learned the pattern, and then they were able to apply it for the future.
How accurate was that? What is it?
I don't know, but it's used like in every ATM now. There is a law like doing this. So it's a bit awkward now, so let's cut it.
תודה רבה.
Uh,
תודה רבה.